So if two measures are related, the rate of change, so we'll talk about this, between them is the slope. The formula for calculating the slope of a line segment passing through 2 points, x1, y1, and x2, y2, can be defined in these different ways. So first, let's just talk about the terminology here. We have two different points. They both have an x-coordinate and a y-coordinate. And to differentiate between the two of them, we call the points in the first one x sub 1. We call it x sub 1, y sub 1. And the points in the second, the coordinates of the second one are x sub 2 and y sub 2. That way we know that they're different from each other. All right, so slope is always referred to with a variable m. So if you ever see an m, it refers to the slope typically. One way to define the slope is rise over run. It's just a quick way of saying it. Rise is as we go from one point to the other, how much do I, rise if I were to go up, but actually drop. So the rise is the distance from here to here, and the run is the distance sideways if I had to go from one point to the other sideways there. So rise over run. It's also called delta y over delta x. Delta is a Greek letter that means the change in y's and the change in x's. And we can define that this way. To figure out the change in the y's, we take one y and subtract the other. So y sub 2, which is this one, subtract y sub 1 over, and then x sub 2, which is this x, minus x sub 1. It really doesn't matter which point goes first or second, but you always start with the same point. So if I start with the second point, subtracting the first y, then I'm going to start with the second x and subtract the first x. All right, so in our picture over here, our graph over here, it asks about AB. So if we wanted to do rise over run, then I'm going to look at this and notice here's one point, here's the other. So to go from B to A, I'm going to go, and I'm going down. So down is negative, up is positive. So if I'm going down to get there, I'm going to go minus 2. And then I'm at this point right now, so I went down, so minus 2. And then I'm going to go to the left, 1, 2, 3, 4, 5. And again, if I go to the left, that's negative. And if I go to the right, that's positive. So since I started here and I went down 2, it's negative 2. And then left 5, it's negative 5. And I get negative 2 over negative 5, which is going to simplify to be, so rise over run, that's going to be the 2 over the 5. So rise over run. You could have also gone right, or I could have gone right here, going up. I could have gone up 2 and then right 5. So that would have been a positive 2 over a positive 5, and I still get 2/5. CD, if I'm going to count and do rise over run, if I start here at C, then to go to the D, I'm going to go down 1, 2, 3, 4. So again, that was down, which is negative. And then, so I'm right, when I went down, I'm right here. And then I'm going to go right 1, 2. So since I'm going to the right, that's a positive 2. And so that's going to give me negative 4 over positive 2, which simplifies to negative 2. You could do negative 2 over 1, but negative 2 when you simplify it. So note the Greek letter delta represents the change in the variable, in a variable. So in example 1, we're going to classify the rate of change for each graph. And so all we're going to note, because there's no counting to do, is it positive, is it negative, is it 0, or is it undefined? So if we want to talk about rise over run, you see this one doesn't rise at all. If I thought about 2 points on the line, it doesn't rise. So the rise is 0, and as I run across it, so this has a slope of 0. On this one, you see that going from one point to another, I'm going to rise. So I'm going up, which is positive, and then running, which is positive. So this is going to be a positive slope. This one, as I go from one point to the next, I'm going to go down, so I'm dropping down, so my rise is negative and over a positive. So that's negative. And this one, there is no run at all, and there's multiple different rises. So I'm rising, but I'm not running at all. So it's going to be like a positive number over 0, which is undefined. So just like in functions, for this input, I can't have multiple outputs. So it is an undefined rate of change. In example 2, it says find the slope of the line through 5, 2, and 7, 8. There's a couple of different ways to do it. One way would be, since we've got a graph right here, is to plot it. So our first point is 5, 2, which is right here. And then we have the point 7, 1, 2, 3, 4, 5, 6, 7, 8 right there. So that defines this line. And what I'd like to do is find the slope of that line. So I need to do rise over run. So rise is I'm rising up 1, 2, 3, 4, 5, 6. So positive 6. And then I'm going to the right, which is also positive. So I'm running 2. So my rise over run is going to be 6 over 2. We could have also done that with our formula. I'll kind of like to write the points underneath each other, where you do the difference in the y's. So 8 minus 2 over the difference in the x's, 7 minus 5, and that gives me also 6 over 2, which reduces to 3. So m is equal to 3.